Volume generated by region bounded by two curves. The volume generated by rotating a region bounded by the curves y is equal to f of x and y is equal to g of x through 360 about the x-axis from x is equal to a to x is equal to b is b is equal to pi the integral from a to b of f of x squared dx minus pi the integral from a to b of g of x squared dx. All right, some simple points to note. One, A and B are the points of intersection of the two curves, and the volume that is generated by the region bounded by the two curves is simply the volume generated by the area bounded by the higher curve minus the volume generated by the area bounded by the lower curve, the x-axis, and of course the lines x is equal to A and x is equal to B. So it's a volume of solid of revolution of the higher curve minus the volume of solid of revolution of the lower curve. Let us see this in action. Example 26 says find the volume generated when the region bounded by y is equal to 3x and the curve y is equal to x squared plus 2 is rotated 360 degrees about the x-axis. All right, so something that's important to the formula is a point of intersection of the two curves. So let's find the point of intersection. All right, and of course it can be points of intersection. So more than likely it's actually points of intersection. Now, at the point of intersection is common to two curves. So the point of intersection is common. It means that y for the two curves are the same at the point of intersection. So x squared plus 2 is equal to 3x at the point of intersection. All right, let's solve this equation. It's a quadratic equation. All right, the first step in solving a quadratic equation is that one side of the equation must be equal to 0 using the method of factorization. So I'm factorizing. All right, so therefore x minus 1 is equal to 0, or x minus 2 is equal to 0. Therefore x is equal to 1, and x is equal to 2, or the values of x at the points of intersection. So therefore the volume, all right, something else I also find useful sometimes is maybe to sketch the curve. So let's do a quick sketch. We have y is equal to x squared plus 2, that's the curve. All right, and that is a simple parabola. All right, and it's symmetrical about the y-axis, and it meets the y-axis at 2. All right, so the next thing we need to do is draw the line y is equal to 3x, which is a straight line. All right, and so the region that is bounded between the straight line and the curve is that region there. Point of intersection is x is equal to 1 and x is equal to 2. All right, so that's just a quick idea as to what my curve looks like, or what my situation looks like. All right, so the volume would be equal to pi the integral from 1 to 2 of f of x, and f of x, which is the higher graph, is 3 x, and we need to square it, dx, minus pi the integral from 1 to 2 of the lower, in this case the curve, which is x squared plus 2, I need to square it, dx. All right, I'm going to find both of these separately. So the first one, pi, the integral from 1 to 2 of 3x squared, which turns out to be 9x squared dx, would be equal to 9 pi. The integral from 1 to 2 of x squared dx, which would be equal to 9 pi, and then I have x cubed divided by the new power, which is 3, and this is from 1 to 2. First, I'm going to replace x with 2, so what I have is 9 pi. Then I'm going to have in bracket I'm going to have 2 cubed over 3. Then I'm going to replace x with 1 cubed over 3. So what I have is 9 pi, and in bracket 8 over 3 minus 1 over 3. So my final answer, this becomes 9 pi multiplied by 7 over 3, which turns out to be 21 pi cubic units. All right. So all I did was I found the first integral. Now I have to find the second integral, and then I have to subtract. So the second integral is pi, the integral from 1 to 2 of x squared plus 2 squared dx. This is equal to pi, and then it's going to be integral from 1 to 2. So let's expand this. We have x to the 4 plus 4 x squared plus 4, and integrating this with respect to x. This becomes pi. All right, so now we're integrating. We have x to the 5th power divided by the new power of 5 plus, all right, there's an error here. I'm 100% sure of it. This should have been, oh, it's not an error, it's actually there. Just so it looks like a plus. So this is 4x squared plus 4. So this becomes 4x to the 3rd power over 3 plus 4x, and this is from 1 to 2. Now next I'm going to replace x with 2, then I'm going to replace x with 1, so it's pi, and what I have is 2 to the 5th power over 5 plus 4, 2 times 2 to the 3rd power over 3 plus 4 times 2. So I replace x with 2 minus, I'm going to replace x with 1. So it's 1 to the 5th power over 5 plus 4 times 1 to the 3rd power over 3 plus 4 times 1. And next I just simply need to work this out and try not to make errors. So I have pi, and this becomes 32 over 5 plus 4 times 8, which is also 32 over 3 plus 8 minus, to the right I have 1 over 5 plus 4 over 3 plus 4. All right, and then this becomes pi. Then I have 32 over 5 plus 32 over 3 plus 8 minus 1 over 5 minus 4 over 3 minus 4. This is pi. The LCM, it's 15. So I have 15 here. 5 into 15 goes, right before I went to LCM. This is pi, the integral of, sorry, not the integral, pi And in brackets, I have 32 over 5 plus 32 over 3 minus 1 over 5 minus 4 over 3 plus 4. Because 8 minus 4 is 4. Now LCM, which is 15. So I have 15 here. So my pi outside. 5 into 15 is 3. 3 times 32 is 96. So this is 96 plus 3 into 15 is 5. 5 times 32 is 160. Minus 3 minus 20 plus, alright, plus, let's just go straight ahead, 60. So if I put this over 1, 1 into 15 is 15, and 15 times 4 is 60, so plus 60. Alright, and so we can work this out to be pi multiply by, and this is 293 over 15. 293 over 15. And so this answer becomes 293 pi, this is over 15. All right, so obviously we're not finished because we did it separately. So the volume would be 21 pi, which is what we got from the first integral, minus 293 over 15 pi. All right, so let's put this over 1, find the LCM, which is 15. This becomes 315 pi minus 293 pi. And so our final answer, V, the volume generated when the area bounded by the straight line and the curve is rotated 360 degrees about the x-axis, that volume V is equal to 22 over 15 pi cubic units. All right, so that's the end of the question.